Hi, so in this video, we will be talking about the periodic trends with regard to the metallic character. First of all, what do we understand by metals? Generally, whenever you think of metals, you might think about substances like iron, copper, gold, silver, which are hard, they are shiny, they have lustrous appearance, they are malleable like the aluminum foil, are ductile like the copper wire, and they are generally good conductors of heat and electricity. But for the periodic trends, when we consider metals, metals are those which have the tendency to lose an electron from its outermost shell. And we already know that those elements are those which have the valence electrons 1, 2, and 3, which have the capacity to lose an electron. So now let us see what we are learning in today's video. So today we will be talking about ions because in the case of metals we are talking about an element losing an electron. So particularly we are talking about positive ions which are also called cations. Positive ions are formed when the number of protons is greater than the number of electrons, and they are generally called electropositive, meaning they do not like electrons. They want to get rid of those extra electrons to get the noble gas configuration. The second thing we will talk about is something called ionization energy. Now, ionization energy is the energy required to make an ion, and here in general, it is the energy required to remove the outermost electron from its valence shell. Now, when we look at it, for ionization energy, we are quite concerned with atomic size. The bigger the atom, the easier it is to remove an electron. Also, it is easier to remove one electron than to remove two or three electrons. And the third thing that we have to talk about is the metallic character, which is the general tendency in which the ease of an element losing an electron is taken into account. Now, let's also have a recap of what we know. We know about the shells in the periodic table going across the period and down the group. We also know that the number of shells is denoted by the principal quantum number n, and it remains the same across the period, while across the group, the number of shells increases by 1 as you go down the group. The second thing that we know is related to the atomic size. We are talking about the effective nuclear charge when we talk about the atomic size. And we have already understood that across the period, the atomic size decreases because the electrons are overcrowded in one shell only. So the effective nuclear charge increases and then it pulls the atom closer towards the nucleus. We have seen that down the group, the atomic size increases. This is not related to the effective nuclear charge, but overall, when a general shell increases, then the size increases. Now, to think about these in terms of the ionization energy. Ionization energy is measured in the terms of electron volt. Now, let's just think of what should happen to the ionization energy. Ionization energy is the energy required to remove the outermost electron. If you are to think about a period, then across a period, the number of electrons in a single shell keeps increasing. So it is more and more difficult to remove an electron because as you go across the period, you're going from being able to lose electrons into having the tendency to gain electrons. So ionization energy, that is the energy required to remove the outermost electron, will keep increasing. While if we are talking down the group, then the number of shells are increasing, the size is increasing. So the nucleus is having lesser and lesser pull towards the valence electrons. So energy required to remove the valence electrons will be much lesser. Therefore, the ionization energy decreases down the group. Now let's look at the trends in the periodic table. First of all, we will be talking the trends down the group, second across the period, and in turn the general trend. And currently the trend that we are going to be focused upon is the metallic character. And we are going to use all that we know about the number of shells, the size, and the ionization energy to figure out what happens with the metallic character down the group and across the period. Now here in this periodic table, we have seen that metallic character increases down the group, while metallic character decreases across the period. Now again, let me remind you that metallic character is on the basis of the ease of removing the outermost electron. Now, if you look into these groups where alkaline metals, apart from hydrogen, obviously, the group 1, they all have one valence electrons. So it is easier to remove one valence electron than it is to remove the two valence electrons in group 2, or three valence electrons in group 13, or four valence electrons in group 14. While you go to the five valence electrons, they end up having the tendency to gain electron, and by the time we end up into the noble gases, they are quite stable with the filled octet shell. If you look here, the tendency to lose an electron will keep decreasing. So the metallic character will keep decreasing. Now let's look down the group. Now for group 1, it has one valence electron in the outermost shell. So for lithium, the third electron is in the second shell, while for cesium, the 55th electron is in the sixth shell because it's in the sixth period. So it is easier to remove the last electron from the sixth shell than it is to remove the last electron from the second shell, because the second shell is closer to the nucleus than the sixth shell. So when we go down the group, the metallic character keeps increasing because it is easier to lose electrons as you go down the group. The same is the case if we were to look at non-metals. If I were to talk about FCl, Bri, and so on, even here, the tendency to lose an electron would be greater down the group than the members above those groups. Same would be the case for helium. It's noble gas family. Radon would have a better tendency to lose an electron than its counterpart helium, even though all of them are in the same group and they are all noble gases. So the general trend that we see here is something like this. The metallic character will increase in this general direction. So here, if you see, you have helium, neon, the noble gases, which is the least metallic. They are noble. They do not want to react. To if fluorine and so on, they are non-metal. They want to gain electrons and not lose electrons. And when you go across, you will end up with francium. And now this is the most metallic element, which has the tendency to lose electrons as fast as possible. So generally in a periodic table, if we notice, most of the elements are metals, which is the S block, the D block, some of the P block, and almost all of the F block. Now let's try to figure out the exact reason why the metallic character decreases across the period. Now we know that as we go across the period, atomic number increases by 1. And that is why the nuclear charge keeps increasing. And the atomic size decreases. The ionization energy increases. It is very difficult to remove those outer electrons. And that is why the ease to remove an electron decreases. And thus, across the period, when we move, we go from being metals to non-metals. So this is the general reason why the metallic character decreases across the period. Now let us look at reason why metallic character increases down the group. We know that down the group, atomic number again keeps increasing, and the number of shells keep increasing successively by 1 as you go down. And the atomic size now increases due to the account of the extra number of shells. So the ionization energy decreases. The electrons are held loosely in a group. So it is easier to remove that electron. And we know the ease of removal of that electron is what defines the metallic character. So when you go down the group, the character generally becomes more metallic. Now let's look at what might happen to those of nonmetals. So nonmetals are displayed here. Apart from hydrogen, all the other elements are there in the P block. Now, generally, all the nonmetals that we know of are gases, apart from bromine. They are non-lustrous, they are not malleable, they are non-ductile, and then they are also generally poor conductors of heat and electricity. And as a counterpart to the metals, nonmetals are those which have the tendency to gain an electron. So now we are going to be talking in the opposite direction of what happens with metals. Now, if you were to talk about nonmetals and the kind of ions that they would end up forming, we would see that most nonmetals will form anions, which are negatively charged ions. This is because the number of electrons is greater than the number of protons. These nonmetals would like to hog an electron or more to end up having the configuration of the nearest noble gas. And that is why they generally like to gain an electron, and they are very eager to make sure that they get those extra electrons. Now, this is also marked by a property called electronegativity. Electronegativity simply is the tendency that the nonmetals have to attract the shared pair of electrons towards itself. Now, this is because, again, since they like having those extra electrons around, they want to attract it towards themselves as much as possible. And nonmetals are generally the most electronegative elements in the periodic table. The counterpart for nonmetals, the metals, they are electropositive, while nonmetals are electronegative. Then when we talk about the non-metallic character, we can see that it is determined with the ease with which the element can gain an electron. Talking about the counterpart where metals would try to lose an electron. Can you figure out how nonmetals would react and the non-metallic character in the periodic table? Let's discuss this in another video. Happy learning!